In recent years, aging research has shifted from treating age-related diseases reactively to understanding and actively targeting the underlying biological mechanisms of aging itself. At the forefront of this transformation is vitamin B3 in its forms of nicotinamide riboside, NR, nicotinamide mononucleotide, NMN, and nicotinic acid, which has emerged as a cornerstone nutrient in longevity science. Through its critical role in NAD metabolism, vitamin B3 influences energy production, DNA repair, sirtuin activation, and mitochondrial health, positioning it as a central player in strategies to extend health span and support vibrant, resilient aging. The breakthroughs in this area are redefining how scientists and clinicians view the aging process and are opening new avenues for interventions that enhance vitality across multiple organ systems. One of the most transformative discoveries in recent aging research is the central role of NAD in cellular health. NAD levels naturally decline with age, leaving cells with reduced energy production, compromised DNA repair, and diminished stress response capabilities. This decline affects virtually every organ system, including the brain, heart, kidneys, liver, and skeletal muscle, contributing to cognitive slowing, cardiovascular stress, metabolic imbalances, and frailty. By supplying the precursors needed to replenish NAD, vitamin B3 directly addresses this fundamental deficit, restoring the energy and repair mechanisms that allow cells to function at youthful efficiency. Early human and preclinical studies have shown that NR and NMN supplementation can significantly raise NAD levels, enhance mitochondrial performance, and improve cellular resilience, suggesting that B3 may help delay or even partially reverse aspects of age-related decline. Closely linked to NAD restoration is the activation of sirtuins, a family of enzymes known to regulate metabolism, stress resistance, and DNA repair. Sirtuins act as guardians of cellular integrity, coordinating adaptive responses to metabolic challenges and promoting efficient energy use. By raising NAD levels, vitamin B3 enhances sirtuin activity, which in turn improves mitochondrial function, reduces oxidative stress, and supports genomic stability. Experimental studies demonstrate that this pathway influences lifespan and health span in model organisms, and early human research suggests similar benefits in metabolic function, cardiovascular markers, and cognitive performance. The ability of vitamin B3 to modulate sirtuin activity represents a powerful mechanism for systemic rejuvenation and is a key reason why it has become a central focus in longevity science. Metabolic rejuvenation is another area where B3 research is making an impact. Aging cells often exhibit metabolic inflexibility, reduced fat oxidation, and impaired glucose regulation, contributing to weight gain, insulin resistance, and chronic inflammation. NAD precursors enhance mitochondrial energy production and improve the efficiency of metabolic pathways, allowing cells to switch more effectively between energy sources and maintain homeostasis. Studies in older adults have shown that NR and NMN supplementation can improve insulin sensitivity, boost muscle mitochondrial capacity, and reduce markers of inflammation. These changes not only support day-to-day energy and vitality, but also address underlying mechanisms of age-related diseases, suggesting that B3 may provide both preventive and restorative benefits. One of the most exciting aspects of this research is the systemic nature of the benefits. Because NAD and sirtuins are fundamental to nearly every cell type, B3 supplementation has the potential to support multiple organs simultaneously. Improved mitochondrial function in muscle enhances mobility and endurance, while neuronal benefits help preserve cognitive clarity and memory. Cardiovascular and renal support may reduce arterial stiffness and enhance filtration, while skin cells benefit from better repair and protection against oxidative stress. This multi-organ effect distinguishes vitamin B3 from many other interventions, offering a holistic approach to maintaining resilience, strength, and vitality throughout aging. Safety and accessibility further enhance the promise of B3 in longevity science. NR and NMN have shown excellent tolerability in clinical studies, with minimal side effects and broad applicability across age groups. Dietary sources such as fish, poultry, mushrooms, and whole grains provide additional, everyday support for NAD metabolism, making it possible to integrate these nutrients seamlessly into a lifestyle approach to healthy aging. When combined with exercise, balanced nutrition, and stress management, B3 supplementation complements the natural biological pathways that sustain energy, repair, and resilience. The implications of these advances are profound. Aging is no longer seen as an immutable decline, but as a dynamic, modifiable process, with vitamin B3 acting as a practical and scientifically validated tool to support cellular health and systemic rejuvenation. By restoring NAD, activating sirtuins, and enhancing metabolic flexibility, B3 is changing the landscape of longevity science, offering the potential to extend health span, reduce age-related disease risk, and improve overall quality of life. As research continues, it is increasingly clear that vitamin B3 may serve as a foundational pillar in the next generation of anti-aging strategies, empowering people to maintain energy, cognitive clarity, and resilience far longer than previously imagined.